Hi, Year 10. Okay, so this is the experiment that you will hopefully do as your required practical when we come back to school. Okay, it's called the ripple tank experiment. And essentially what it allows you to do is apply the equation frequency times wavelength equals wave speed. So you can work out the speed of the wave. Okay, so what you've got is an experimental setup like this. Now, what you will most likely be asked in an exam is to identify a method or describe this method of how you would calculate wave speed. So there's two methods. The first one is this. Okay. Now, key thing that you, that you can do on page 74 in your purple revision guide, there are the methods that you need to calculate wave speed. Okay. Now what I will do is I'll snap a photo of those and post them onto the chat, so you can use those as well just in case you don't have the book. Otherwise, page 74 in your book has all the information you need. But what I'm going to do is I'm going to talk you through it, and then you will have to copy up the method in a little while. So you'll have a setup like this. It might look like this. The diagram may change slightly, okay? But what you need to do is identify what you've got. So you've got, actually I'll use this one. You have a light, and the light is shining through a tank of water, clear tank of water, and what's happening is you've got a little dipper in the water which is connected to a motor, which is connected to an alternating power supply. Now, as the alternating current goes backwards and forwards, it causes the motor to vibrate backwards and forwards, creating ripples in the water. As the light shines through, the shadows of those ripples are passed onto a screen, and you can then see the waves. Okay, so that is basically how the ripple tank works. Okay, and you can see the experimental setup here is actually very, very similar. There's a ruler there. You might want to think, right, what could that be used to measure? Okay, so firstly, let's talk through the method. Now, you can pause the video and copy up this exact method, or as I said, there is a method on page 74 in your revision guide. Okay, but essentially this is what you need to do. So, step one, set up the ripple tank. Pour the water to a depth of about 5 millimeters into the tank. Adjust the height of the wooden rod so it just touches the surface of the water. Switch on both the overhead lamp and the electronic motor. Okay, so at the moment, all it's showing you how to do is set up the experiment. Adjust the speed of the motor so that low frequency water waves are produced. Now, in order to do that, what you can do is you can set the frequency on the power supply. Okay, it's an alternating power supply, so you would simply set it on there. Adjust the height of the lamp so that the pattern can be clearly seen on the card screen. So basically, the first few steps are essentially just showing you how to set up the experiment. Right, now this is where we need to start applying a bit more knowledge. So, place the meter ruler at right angles to the waves shown in the pattern on the card. Measure across as many waves as possible and then divide that length by the number of waves. This gives the wavelength of the waves. Right. Now, here's your first problem. You've got a ruler and you can measure the length of the waves. So from there to there, that would be the wavelength. However, there's a practical problem here. The waves are going to be moving across, so it's going to be quite difficult to measure the waves as they move. So what you need to do, there are two possibilities. If you use a strobe light or a stroboscope, what that will do, it will appear as if the waves are still, even though they are still actually moving. A strobe light gives the appearance of the waves being completely still. So if you set up a strobe light, it is very simple to then take the ruler and simply measure the wavelength. So if we just go back, place a ruler at right angles to the wave on the card, measure across the waves, and divide that length by the number of waves. Okay, so what they're suggesting here is that actually you measure that entire length and then just try and count how many waves. That's going to be difficult. I would recommend you use a strobe light of sorts. Right. How then, so you've got your wavelength, how then do you work out the frequency? So you count the number of waves passing a point in the pattern over a given time, say 10 seconds, then divide the number of waves counted by 10. This gives the frequency of the waves. Okay, so once again, back to this. Now, it's going to be very difficult to count the number of waves passing a point each second. Remember, the frequency is how many waves pass a point each second. So if sort of like half a wave goes across, you can't really see that from your light. So what you would need to do is count the number of waves for 10 seconds and then divide that by 10. Okay, that will give you the frequency, the number of waves per second. Because say, for example, if you get 17 waves in 10 seconds, you'll have a frequency of 1.7 if you divide it by 10. But how would you know what 0.7 of a wave looks like? So it's actually a much more accurate way of doing it. Okay, so back to our method. Count the number of waves passing a point every 10 seconds and divide by the number of waves counted by 10. That gives the frequency. And they really love that in the exams. Do make sure you include that. And then calculate the speed of the waves using the equation frequency times wavelength. So essentially, I've described to you how you do this. Okay. You need to describe how you set up the experiment and the method you would use. You would always include the equation which you would use. So, a couple of things you can do. Pause the video and you can copy up this diagram and then this method. Just move that down for you. All right. Or go to page 74 in your revision guide and you can use that one as well. Okay, so pause the video now and do that, please. Right, welcome back. So the other practical that you need to know is this one, and you should probably have a diagram like this drawn in your book. Some of you will have already clocked this one on page 74 in your revision guide. This is the other required practical that you need to know. So essentially how it works is you have a vibrational generator, sometimes called a transducer, connected to a power supply, and again that would be an alternating current power supply. So again, the current going backwards forwards, which means this would go up and down. And you can probably sort of work out what happens. As the vibrational generator goes up and down, it creates a wave between here and the wooden bridge. And the tension is kept on the string or elastic cord by hanging weights over a pulley system. Okay, so you've got a diagram if you're set up there. A method that you would need to be able to describe in your book. So you could say set up the apparatus as shown, switch on the vibration generator, the string should start to vibrate. Now, you can adjust the tension on the string by moving the wooden bridge backwards and forwards until you see a clear wave pattern. The waves should look like they're stationary. So essentially, as it goes up and down, see, like that, the waves will give you this sort of pattern. It will look like it's stationary, okay, because they're moving so rapidly. Use a metal ruler to measure across as many half wavelengths as possible. A half wavelength is one loop. Then divide the total length by the number of half waves, multiplying this number by 2 for each one. Okay, now this is where it gets a little bit confusing, so I'm just going to explain this. If you see from there, say to there, that's what you'd call a loop. But that's only half the wavelength, because look, it's going up and then down. In order for it to be a full wavelength, it's got to go up again to there. Okay, now that's actually quite difficult to measure. So what you do is you measure that distance there. That is half a wavelength, and then simply get the wavelength, you'd multiply it by 2. Right, the frequency is the frequency of the power supply which you set. Okay, so your alternating current power supply will be set, and you do that, and then you simply do the frequency times the wavelength to get the wave speed. So once again, you would describe how you would do the practical. You must include the equation which you would apply in there. Okay. Now, once again, on page 74, there is a description of how you would carry out the method for this required practical. Okay, so a couple of little things about this. You need to be very precise in how you describe this method in the exam. Okay, so do take the time to read both of the method, really pay attention to the words which are in bold and underlined, okay? Because those are very, very important to make sure you apply those correctly in the exam. Okay, right, so to be completely honest, it should take you about 10 to 15 minutes to write out the method. Remember, these are probably going to be 6-mark questions, so you need to make sure you are being really, really thorough with these. So pause the video now and please write out this second method. You can use the uploaded picture from page 74, or you can simply use what I've got given you here. Okay, so this probably should have taken you about 25 minutes if you've done it properly. What you can now do is have a quick go at the question at the bottom of page 74. Okay, that'll probably take you about 2-3 minutes. It's not particularly long. And then in assignments, there is a link with a bit of an introduction to the next topic, which is reflection. Once you've watched the video link, I'd like you to bullet point everything you know or think you know already about reflection. Now, some of this is quite basic, but some of it is actually quite difficult, and there will be quite a lot coming your way. Okay, so once you've finished writing up your methods, have a quick go at question 1 at the bottom of page 74, watch the link in assignments, and bullet point everything you know or think you know about reflection. Okay, the reflection of waves. All right, I'll be online as normal, and good luck.